We're on to question 8.3 and more specifically 8.3.1. Let's have a look. Points E and W are two variable points on the derivative of f and are on the same horizontal line. H is a tangent on the first derivative at E and G is a tangent on the first derivative at W. H and D intersect at D and B. And A and B. And A and B are nothing other than x and y coordinates. Write the value of A. So they want us to find the x coordinate. So first of all, we have 2 points, and these 2 points are in exactly the same y coordinate. So it's on the horizontal plane. So it'll look something like this. So I've kind of given, well, actually 4, and then I've got a 5th point over there, which I'm going to explain later. But if we start drawing these tangents, what you'll soon realize is crosses at a certain point, and that's that point D, which is the x and y coordinate. And then I just drew another tangent, and what you'll see, it crosses at another point. But what is relative to all of these, it doesn't matter where the tangent is, except for right on top, we'll get to that one. There's a line which one can draw, and it literally goes straight through the turning point. So actually, all we need to do is work out the x coordinate of the turning point. And that's pretty simple, seeing as we know what the x coordinates are. We've got P and Q with 2 x coordinates. We can then go and say the turning point will equal minus 1/3, which is the 1 coordinate, plus 1, which is the other x coordinate, and we divide that by 2. That'll give us the center of the line. And if you punch it into a calculator, you'll see that the turning point is 1/3. Now that's the x coordinate. Therefore, A is equal to 1/3. Question 8.3.2. Determine the values of B for which H and G will no longer be tangents to the first derivative of the function. So B is referring to, as you can see over there, to the y value. From the previous example, we know that the turning point on the x is at 1/3. Now, the question is determine when a tangent will no longer be a tangent. We know that the last time a line will be a tangent is over here. So if we go just a little bit to this way, you'll get a tangent over there. And then as you go down further and further, the tangent will just cross this line a bit higher and a bit higher and a bit higher. However, if we go a little bit lower, so let's say we want to get this mark, what you'll realize is that this is not a tangent anymore, because it's now going to cut the graph. Let me just draw this line. It now cuts the graph in 2 places, there and there. And what we can do is you can go to just below that line. And what you'll get is you will not get a tangent, you'll get a secant. And then you'll see it'll cut over there and it'll cut over there. What we need to do is we need to find where y is the last place where it can be a tangent. And then anything below this will be a secant and not a tangent. So what we have to do, we just have to figure out what y is. And how do we do that? We take the first derivative, which is minus 3x squared plus 2x plus 1. We substitute 1/3 because that's we know is x. 1/3, which equals minus 3 times 1/3 squared plus 2, 1/3 plus 1. If you punch it into your calculator, you'll see we'll get 4/3. So what we're saying is D is, well, A value is 1/3, and then the Y value will be 4/3. More importantly, we know that that is here, 1/3 and 4/3. So what we're saying is anything below 4/3, it's not a tangent. Therefore, B, that's B, if it's less than 3/4, it is not a tangent. Thank you for watching the video. If you have any questions, please drop your question in the questions below. We'll read and respond as soon as possible. If you need more help with math, please click the link below. That goes to my channel and go view what we have available there.